We use basically Pythagorean theorem to come up with our formula for r. R is the square root of x squared plus y squared. We wrote down our 6 definitions. This is not sin, this is sine, and that was y over r. Cosine was x over r, tangent is y over x. Then, if you know these 3, the others are just reciprocals. The reciprocal of sine is cosecant, so that's r over y. Reciprocal of cosine is secant, so r over x. And reciprocal of tangent is cotangent, x over y. You do need to know these definitions. If you need to make yourself 6 little flashcards to memorize them, you can. And very, very useful to remember which ones are reciprocals, because then you really only need to learn the first 3 and you can just flip them to get the second 3. I usually remember like S's and C's go together. So if I have sine, its reciprocal is the cosecant. Cosine starts with a C, its reciprocal starts with an S. Cosine goes with secant. Whatever trick you need to memorize that. I also used SOHCAHTOA to help relate this if we were talking about a triangle, which we aren't always. That's why we have to have the x, y, and r. But if we were talking about a triangle, this was your r, horizontal distance, think about the x-axis. So that's your x, vertical distance, y-axis is up and down, so that's your y. So sine is opposite over hypotenuse. So from here, the opposite side is y. Hypotenuse is always r, so sine is y over r. Just another way to think about it. And which one did I say was the reciprocal of sine? Cosecant. An S and a C goes together. Cosecant. Ca means cosine is adjacent over hypotenuse. Adjacent means touching, but it's the side other than the hypotenuse. So that's x over r. Reciprocal cosine is secant. Tangent, TOA. Tangent's opposite over adjacent. So from here, the opposite side is y. The adjacent side, the touching side, is x. And reciprocal of tangent is cotangent. All right, let's start with an example. So the terminal side of an angle theta in standard position passes through the point 12, 5. Find the values of the 6 trig functions of theta. I'll give you a second if you want to jot that down before I start working it. Theta's in standard position, so there's your theta. 12, 5, what quadrant would that be in? Quadrant 1, because they're both positive. I'm not going to be real precise here. You certainly can. So that's your point on the terminal side. I want the 6 trig functions of theta. The picture is not really necessary. I'm just using it to kind of show you what our angle looks like. We know from ordered pairs, what's the x value? 12, because an ordered pair is x comma y. Our y is 5. You have to first find r. So you can either use the formula for r. If you forgot the formula, we know it just comes from this picture, Pythagorean theorem. So the formula I told you, r is the square root of x squared plus y squared. Or if you needed to, just start at the beginning. X squared plus y squared equals r squared. So you can start at either place. We know r will always turn out to be a positive number. So we get square root of 12 squared plus 5 squared. So 144 plus 25 is 169. So my r is 13. So that's your first step. You have to be able to find r. Now we want our trig functions. Notation, you have to put the theta. I don't just want SIN equals. We have to write sine, so SIN, then you put the theta symbol. Because eventually we're going to talk about, in a triangle, finding our trig functions from different angles in the triangle. And so we need to get in the habit of labeling what angle we're talking about, because it does change depending on your viewpoint. So sine, remember we said was just y over r, so that would be 5 over 13. I do want these in lowest terms, so if you had 5 over 10, reduce that to 1/2. I want exact values, so if my r came out to be radical 5, I want you to keep it as radical 5, do not change it to a decimal. And then we also need to make sure we never leave a radical in the denominator, so all of our algebra rules apply here. Cosine theta, cosine is x over r, so my x was 12 over r, which was 13, 12 over 13. Do not change this to a decimal, keep it in fraction form for your final answer, just fraction in lowest terms. Tangent is y over x, so that would be 5 over 12. And then we need the reciprocals. What's the reciprocal of sine? Cosecant, CSC. Cosecant theta is then r over y, or 13 over 5. And that's why we keep these in fraction form instead of changing them to decimals, because it's a lot easier to just do the reciprocals that way. Reciprocal of cosine? So secant is r over x, so 13 over 12. And reciprocal of tangent? Cotangent. That's the x over y, so 12 over 5. You guys ready for one? You don't necessarily, when you're working the problems, you don't have to write, sine equals y over r. You can just say sine equals 5 over 13. I just wrote the definitions to help us learn them. Repetition. So the next one, I want you to work it out on your own, please. All I'm changing is the ordered pair here. My x value is positive 8. My y is r. You can do, if you remember the formula, square root of x squared plus y squared. So 64 plus 36 is 100. R is always positive. If you did draw this, my point 8, negative 6 is here in the fourth quadrant. It's talking about an angle in standard position. It's talking about this angle down here. This, in a triangle, you say sides are never negative. That's why we think about it as x, y's, and r's, because we can have a negative x or y. R will be positive, but x and y could be positive or negative. So sine theta, y over r. Go ahead and reduce to lowest term, so that's negative 3/5. And if you know sine, you automatically know its reciprocal. Cosecant would be a negative 5 over 3. Just flip it. Cosine, x over r, so 8 over 10 reduces to 4 over 5. Reciprocal of cosine is secant, so it would be 5 over 4. Tangent, y over x, so negative 6 over 8 reduces to negative 3/4. So cotangent is negative 4/3. Is that one okay? Let's say I ask the question a little bit differently. So I'll give you a second to jot this down if you want. This initial part is the same. We're just talking about finding the 6 trig functions. But what you want to write down, the terminal side is defined by this equation. I did not give you a point on the terminal side. I gave you the equation of it this time. We need a point. We need x, y, and r. We are just going to find a point on the side. The values of our trig functions, it's actually the same for every point on the side. So for instance, on this one that we just did, if I picked a point out here, or a point way back here, or back here, no matter which of those I pick, my final ratios will turn out to be the same. So I just need some point on this line. We're just going to start by picking an x value. I said x is less than or equal to 0. Do not do 0 because that 0, 0 is the origin. So I need a positive or negative number here. Which one? Negative. So give me a negative x number. -1. So if I do that, if we want to find our y, we're going to plug our x in. Divide by 2, and my y is -3/2. Nothing wrong with that. We can use it. If you don't like the fraction, what could you do? Pick a different x value. So do you guys want to deal with the fraction, or do you want to pick a nicer number? What might be nicer? Okay, let me show you this way. There's a couple options. If you take an x and you solve it and get a y that's a fraction, what would I have to multiply my y by to get rid of that fraction? 2. So you can multiply your x by a 2 as well. So then my x is a -2 and my y is a -3. If you check those in the problem, 3 times -2 is -6, minus -6, so -6 plus 6 does equal 0. So if you ever get a fraction, like if this one had a denominator of 9, I would take both of them times a 9, and then we can have nice numbers to work with. Now find our r. So square root of x squared plus y squared, so -2 squared plus -3 squared. So 4 plus 9, I get the square root of 13. Does that reduce? No, so I'm just going to keep it. If you have something like the square root of 8, you do need to break down any perfect squares that go into it. You're breaking it into a 4 and 2, so if it's divisible by any perfect squares, go ahead and reduce that part, but otherwise we'll just leave it like this. So now my 6 trig functions. Sine is y over r, so -3 over radical 13. But can we leave a radical in the bottom? Nope. So what would I do to get rid of that? Multiply by radical 13 on top and bottom. We get -3 radical 13 over 13. What's the reciprocal of sine? Cosecant. So cosecant we would just flip. Would you want to flip the final answer or before we move the radical? Yeah. If we just flip that one, we get a negative radical 13 over 3. Okay, cosine theta, x over r. So my x was -2, r is radical 13. Have to get that radical off the bottom. So we get -2 radical 13 over 13. What's the reciprocal of cosine? So we know secant automatically if you take the one before you flipped, so it's just r over x. So negative radical 13 over 2. Tangent is y over x. So negative 3 over negative 2. To reduce that, just make them both positive. Negative divided by a negative is positive. And then cotangent is the reciprocal of tangent. So it would be a positive 2/3. Any questions there? Let's do one last example and then I'm done for today. So same thing. Here's our equation. X plus 2y equals 0, and my x is greater than or equal to 0. So if we start with we have to make up an x value. It has to be something that fits this requirement. So what x do you want to use? 2. 2? And we could everyone in here could pick a different x and you'll still get the same answer. So to find y, if we plug that in, so 2y equals negative 2. So then my y would be a negative 1. Okay, find r. So r is the square root of x squared plus y squared. So 2 squared is 4, negative 1 squared is 1, and r is the square root of 5. So how do I get my sign? Y over r. So negative 1 over radical 5. Can't leave the radical on the bottom, so if you multiply it on top and bottom, we get negative radical 5 over 5. Reciprocal of sine is cosecant, so that's just your r over y, or you flip your sign. So you get radical 5 over negative 1. You can just change that to a negative radical 5. That's fine. Are you all right so far? So cosine x over r, so 2 over radical 5. This gives us 2 radical 5 over 5. Reciprocal of cosine is secant, so that's your r over x. So radical 5 over 2. Tangent y over x, so negative 1 over 2. Then, cotangent x over y, 2 divided by negative 1, or you could just say negative 2. Alright. Any questions or issues with this stuff? That's really the end of where I wanted to get to today. So we're ready for the first chunk of homework. If you would open your books up to page 26, I do want to talk about one part on this. to do okay, most of these are pretty short. The first few just have you draw a picture of your angle and tell what x, y, and r are going to be. The 26 through 44 even, these are very fast problems. I just want you to look at one similar. So let's say I did problem 25 for you. That's not one of the ones you have to do, but it tells you you're in quadrant 2, you're doing x over r, and it wants to know if it's positive or negative. Okay, all you have to think about is if you are in the second quadrant, is your x number a positive or a negative number? Negative. And we know r is positive no matter what. If you take a negative divided by a positive, your answer is negative, and that's your answer. Okay, so quite a few of these, your answer is just a positive or a negative. If I said like quadrant 3, y over x. So in the third quadrant, y is negative, x is, and negative divided by negative is positive. So that's all you're doing on this.
Are we doing 44 or 46?
46.
Okay.
Did I say?
I don't know.
You said 44 as you're explaining this.
Oh, because this section ends at 44 and then 46 is a new type of problem. So, sorry. Okay, so you've got time to